This problem is about identifying where a derivative is positive, negative, and zero. So one thing we need to remember about the derivative is what it represents. It represents the slope of the curve at a given point, or the rate of change of the curve at a given point. So if we remember from looking at linear functions, slope is positive if it rises from left to right, or the relationship between the output and the input is a positive relationship if the graph increases from left to right, and it's negative, so the derivative would be negative. The rate of change of the curve would be negative if the curve decreases from left to right. And where the derivative is zero is where it's neither increasing nor decreasing, or sort of it's increasing just before and then decreasing just after, or vice versa, sort of that top of the hill, bottom of the valley sort of idea. So for what intervals is f prime positive, we want to take a look at the curve and recognize, take our pen along the curve starting at the far left, and anywhere where our pencil starts to go up toward the top of the page, that's going to be where our first derivative is positive. So if I'm following along, I start going upward, I have a positive slope right there at about 0, and then going upward that way to about, what is that, to 4. Okay, so from 0 to 4, f prime of x is positive. Okay, and just that place, because anywhere else it's not increasing, it's not going upward from left to right. There is not a positive relationship between the input and output. Now on the reverse side, where is it negative? Again, if I start from the left and move to the right along the curve, so at the top left here, and I move along the curve, I am going downward. There's a negative relationship between the input and output. As one increases, the other decreases, so that's where it would be negative. So I'm going to assume that this is a function that continues both up and out and down and out. So from negative infinity to 0 is where one place where it's negative, the derivative is negative. Another place, well, it's not in that middle there between 0 and 4, because we said that's where it's positive, but after that it picks up again and starts to go negative. So in that section there, we're negative. So then from 4 to positive infinity, f prime is negative. All right, so the next question is, for what values is f prime 0? Right, that's it. We're looking for that sort of top of the hill, bottom of the valley, or a place where we might have a change in direction at that one point. So if we consider that on this graph, there is a change in direction. We go from decreasing to increasing, or f prime is negative, and it changes to positive right there at 0. And then there's another change at top of a hill, sort of. Our tangent line to the graph, that's another way to think of it, is the tangent line to the graph is horizontal. So if we picture a pencil moving along the curve, resting on the curve, at the top of the hill here, it would be have a horizontal tangent line, where we have that change. It goes from positive to negative, and if we think about the number line, if we're going through all the negatives and then eventually we hop over to the positives, we passed through 0. So at 0 and 4, f prime of x is 0. Okay. The last question, which has a value closest to 1? And so notice it is positive. Okay, positive 1. F prime at 2, so f prime at 2 would be right about there, which we just said f prime is positive, it is increasing there, or f prime at negative 2. So negative 2 is over here. That's negative, right? F prime is negative there. So which one is closest to positive 1? I would have to say at f prime at 2 we are closest to positive 1, because f prime at negative 2 is negative. The slope of the tangent line at negative 2 has a negative slope. The rate of change of the curve is negative. The relationship between the inputs and outputs there is a negative relationship, for all of those reasons.